Okay, so now we're on with the show, I'd say. So I'm going to do a session here about multi-data center redundancy in Azure PaaS. So everyone knows that, putting a good head or heading for a session is very, very hard. And this is no exception. So I decided to basically call it the redundant Azure platform as a service instead. And I can see that you guys are getting along nicely now. Let's hope that everyone is on point. Yeah, all good. Everyone says it's all good. Thank you very much. So, hi, everyone. How are you out there? Who am I? I am Mikael Sand. I am an Azure integration tech lead at Enfo, or rather Enfo Sweden. But most of my work is spent doing Azure solution architecture, rather, because a tech lead is only part of what I do. Before I joined this stuff, I used to do 10 years of this talk. So I think there might be some of you that know me from there, and it might also be that you will see this down the line, that I used to do a lot of integration. I've been on Azure since about 2009, and that's like since forever. And I'm also a very strong advocate of platform as a service. If you want to hit me up after this session, you could the best way is to find me on Twitter at Mikael Sand. But I also have like a homepage /blog /something on michaelsand.se. So, here's what I'm going to talk about today. What is redundancy? In order to fully understand or grasp why this is usually such a hard thing, we need to go a bit into the academia world and talk about things like RTO, RPO, and the BAC theorem. But if you know that, then you will probably if you already know about all these things, you can just kick back and relax for a while, because then I will walk you through scenarios and demos, and we'll end by questions and suggestions for further study. So why do you want redundancy, and why is it so hard to get a 100% availability? So this came about because it was last October. We had two major outages in Azure Western Europe. And I work for a consultancy firm, and we had a couple of clients actually coming to us and saying things like, how did this happen, and what can we do to prevent it further? So I started looking into this problem, and boy, it's a rabbit hole once you start going into why this is so hard. So I'm going to start by explaining what is redundant? What is redundancy? So choosing your own words, you might say that, well, if you have something that is redundant, it's usually you have a duplication or something. You have a copy. Everything you deploy, everything you show up is, you do it at least twice. So that might be something. If you go into a bit more words for it, it serves as a component that might not be needed to fulfill the needs of the solution. So, you can easily serve up data, but then you need to add additional stuff in order to make that data serving become a bit more reliable, right? So it's not really needed for the solution. But also remember that redundancy is not only for emergencies. You can also use it for planned outages where you need to patch something or update something, or just, you need to turn something off in order to make something great. So this is the most academic thing I found, the inclusion of extra components which are not strictly necessary to functioning in case of failure in other components. Just rolls right off the tongue, right? So now we know, what do we want to achieve, or rather, what is it when we say that something has redundancy? It's the inclusion of extra component. That's not necessarily blah, blah, blah. But then there is something called the BAC theorem. And it basically says you can't have it all. The theorem is like this. It's a quote. It's an actual academic paper written by those guys down there. You can Google if you want to. So when backing up an entire microservices architecture, it's not possible to have both availability and consistency of data. So this throws a bit of, shade on, okay, sure, when we want to have high availability, but of course we want consistency of data, because if someone logs in, if something happens, they should still be logged in. But if you can't do that, if you have consistency of data, let me explain a bit more in depth. So here is your application. It's the orange cube right there in the middle. And you have a database in the backend, and you get calls into that service from the left. It's a simple call. And what you have here is not redundant. Because as soon as you need to do an update, the application will go down. It will become unavailable. So you won't have 100% availability. So that's quite easy to understand, right? But then again, you're smart. So you realize that you can have two. So you deploy everything twice and you say, well, now you have two instances. So therefore you can patch one instance and then patch the other. And therefore you have higher availability. And you go on this road of then doing some kind of microservices thing where you have a lot of applications or instances or versions or whatever, and they can work together in harmony, and you can get high availability for all the requests coming from the left hand side. But then you need to update your database, and the database, when that becomes unavailable, all your applications will become unavailable. So therefore you don't have availability, or worse yet, the database might become totally unavailable. There might be like a crash or disaster or something. So then you don't have availability. You have consistency of data because it's crashed. It's not updated. So, okay, sure, you walk on. And what you say is that you add another database, and then you start some kind of synchronization job between those two. And you label one a primary and the other one a secondary, and you sync the data from there, right? So should the primary database become unavailable, you can always use the second one. So, however, we still run into a problem when it comes to reaching 100%, because whichever syncing mechanism you have between your first and second instance of the database, it will still lag behind. The second, in theory, the second database, the secondary database will always lag behind the first one. Something updates to the database, the sync thing doesn't work before the first database crashes, and the second one doesn't get the sync information, and therefore you're out of sync. You have high availability. You can take down the primary database, have everything point to the second database, but you don't have a consistency of data. You can't have both those things. In order to make sure that both the first and the second are fully consistent, you have to stop all the incoming messages, and therefore you don't have 100% availability. So it's not possible to have both availability and consistency of data. I really hope I'm trying to. I've been hammering this home for a while, but this is a real actual thing on a logic level, right? So then you have the next hurdle. You have something called, there we go. You have something called the RPO and RTO. And these are things that you need to know in order to have a good high grasp of what high availability actually means. So a RPO is the return point objective. So when you restore a backup, you actually go back in time, because between the time you took that backup and the time when it crashed, time passed, and that time will now be lost. All those transactions between the last backup and the actual crash will be lost. So you want as low as an RPO as possible. That would be good. If you couldn't have a RPO of 0, so you return a backup to a state where it was just like milliseconds before. So that would be good. So you want an RPO as low as possible. And then you have something called an RTO, which is a return time objective. And it basically means for how long do you want the business to wait before things get back to normal. And this adds on top of the return point objective in my view. So going back to my BizTalk days, which I had when I was younger and had more hair, was so when I was doing BizTalk, there was usually a return point objective of like 30 minutes, or sometimes even a day actually. So you had constant backups running for 30 minutes. So wherever you decided to return to the last good backup, you would automatically lose 30 minutes. However, in the world of how everything was back then, you also needed someone to make a decision that this is broken. We need to reinstate it to the backup version and make that thing work. That might be as much as 2 hours, or even worse, because it might be in the middle of the night or something. But so typical workday, you had then an RTO of 2 hours. Someone has to say, this has crashed, we need to restore it, and then do the actual restoration to go back to a point of where you were 30 minutes ago, plus those 2 hours. So having an RTO of 2.5 hours might not be that good. So you want that to be as low as possible. But then you have even more hurdles because there is something called keeping state. And now we're like, really, if you're doing integration, this is like the bread and butter for you. This is your backyard. This is what you usually do. And if you're not, then pay a bit of attention, and I think you'll tag along quite easily. But also note that it might be very important to you, even if you're like doing web development, that you might need to keep state. So here is an example of how you usually not keep state. You have a typical request response flow where we're always doing from left to right. And in this particular case, you have a call to an Azure API management service, which in turn calls a backend service, which in this case might be a function, which then called the proper backend service to get some information and then sends that information back. So if your API management thing crashes, then no one can call you. And it doesn't really matter if someone called you before, because you're not keeping state. So you're not keeping the state of someone having called you and you need to return that information back. There might be some guy that has a hand up right now and said, yeah, but it might, yeah, and you're absolutely right. There are certain instances, but this is not 100% true, but bear with me. We're getting to the keeping state thing and you'll see that it's totally different. It's a totally different animal. So keeping state, here's another example. So going again from left to right, because that's the way we read, someone calls your API management API, which in turn calls, in my case here, a logic app, which saves the incoming information in a queue and sends that information, sends back to the sender saying, yes, we received this information. Now, this is a very, very common pattern within integration. It even has a name. It might be something called store and forward. I don't know. But basically what we're doing is that queue thing in the middle. That's where we keep the state. We now own that message and we need to keep it, because sometime down the line, the other service on the right-hand side will call another logic app, which will then get that message and send that back. So we're keeping the state of that message. Now let's dial this up to 11 a bit, and let's see if we can make everyone bear with me here for a while. So please, again, note that I'm using services, I'm using platform as a service. This is just the way I like to do stuff. You could probably do this very, very nicely in code, but then it's very hard to do a good, nice presentation just scrolling through lines of code. So once again, we're getting a call into the API management service. A logic app gets that message and stores it, in this particular case, in an Azure storage account. It might be a blob store or something. And then sends back a response saying, yes, I've got the message. I'm keeping it here for you. And we're keeping that state, because what happens now is that the Azure Event Grid sends out an event to another service, which is not our service. And it says, hey, I got a new message for you. You can pick it up anytime you want to. And that's what someone does after a while. They pick up the message, they call that Azure function, which picks up the information within the message and sends it back out. Again, oh my God, that was a lot of words in a row. However, the main focus here is that you need to keep the state here. And that is a problem when you're trying to build something redundantly. And let me go into a bit to why and how we can build a highly reliable platform. So you want to have a low RPO and you want to have a low RTO, and you also want to be able to keep that state thing. But let's start with how can you achieve redundancy for your clients, right? So this is back again to the initial thing. So here is your application, here's your database or whatever, and you have your users. And your users have a West Europe endpoint, which they send information to. And if they send that information into it, everything works, right? But you want redundancy. So you publish another endpoint, which in this case might be in North Europe. And in this case, how should your users know which endpoint to call? North Europe or West Europe? Or should you make them be aware of the West Europe endpoint is not available anymore, so therefore I should call the North Europe endpoint? So you don't want that. And of course, there's a solution to it. It's called the load balancer. And the load balancer I'm going to talk a bit extra about today is called the Azure Front Door or Azure Front Door Service, kind of depending on who you ask. The Azure Front Door load balancing service is a global routing for web traffic. It doesn't matter where your things are. It's when you create an Azure Front Door, you have to assign it a location for its resource group, but it's a global service. It doesn't. You don't assign it to any. It's not a primary, secondary thing. It doesn't fail over, or it's just a global thing. It's always there from whatever you call, right? It's also an instant global failover. Which basically then means that should West Europe goes down, and that's where your routers are currently going, even though you're calling the Azure Front Door end of it, it's instantly failing over to its partner, which in this case would be North Europe. This is a thing which I know some people find important, that it's a layer 7 thing. I'm not exactly sure why that is important, but now I've said it, it works on HTTP, on the HTTP level. It has been in use behind the scenes for Xbox Live since forever. So this is nothing new. It's new in the sense of it's a commercialized product now, which you can buy actually, but it's been used and tried. And of course, there are other offerings when it comes to these things. There are traffic managers. There's application gateway. There's the famous Azure load balancer. Like, which one should you choose, and how? So they actually did quite a good thing for this. They've done a flow chart. So here you have your flow chart. Which one should I choose? So you want redundancy, right? You want high availability. That's why you're here. And let's start. So we are building things today, and I'm going to build something that is a web service or a web application. So yeah, it is. We're going through yes. So will this be internet facing? Yes, it will be internet facing. So I'm going to go yes. So will I deploy it in multiple regions? Yes, that's pretty much why we're here, right? So yes, we're going to do that. So do you require SSL offload or application layer processing per request? No, we don't actually in this particular case, because everything will be handled by our service. Are we hosting this as a PaaS, IaaS, or AKS? So we're hosting this as a PaaS because we're going to put it in front of Azure API management, and therefore we're using the Azure front door, right? The Azure front door contains some other information and things which I will, given time, show you as well. But this is the way we arrive at. We're going to use Azure front door. So going back to this thing again, it's this thing. So you put your Azure front door in front of your West Europe or your North Europe endpoints, and you have your users call the front door endpoint. And if you want to fail over between North Europe or West Europe, or you have to fail over, you can do that without the user even knowing, actually. Okay, so now the keeping state redundantly. So what you need to do, you have to save data in some kind of centralized store. Going back to that earlier image, you're perhaps saving data to an Azure Blob Storage. And you need that data to be synced. You need it to be highly available for all your services, for all your data centers, which you have deployed this thing in. And you will preferably not also, might be a bit on the cheaper side. And it would also be preferable if I didn't have to think too much about it, because why? That's why I buy stuff from Azure, because I don't need to think about it. So of course, there is a service like this. It's called Cosmos DB. Yes, it strikes again. So you can use this as a very, very good candidate for something very awesome if you configure it as something called a multi-master. Because if you configure it as a multi-master, all your data centers will only get one endpoint into the Cosmos DB on which to write and read the data. And this means that your applications can only have like one connection string. Write to Cosmos DB, read from Cosmos DB. Your application does not need to bother itself with which data center am I reading to from. And you don't need to worry about that either. Because what happens is that under the covers, they do this amazing sync algorithm, which guarantees a 99.999% SLA for all your requests to Cosmos DB. Why not 100? Well, once again, the BAC theorem explains why, but also the speed of light. If Microsoft were able to surpass the speed of light, they would be doing something even cooler than what we saw the Dragon doing the other day, right? So they will basically then bend time, and things will be quite cool if we can do that. But no, they can't. So you have a problem with the speed of light. However, as a service, if you're using this, you simply configure it as a multi-master and say, I want my 2 data centers to be, and I will do this and I will show you. It will be in the East US and West Europe. And that's it. You don't need to do anything else, and everything just works. It's a truly key current available service for you. You get one global endpoint, the entry point. That's the one I was looking for. So moving on, this is kind of the service thing I'm going to show you at the end of the demo, but this is we have a service here. It's postman, of course. It will call my Azure front door, which will then route that message to the to one of our endpoints. I realize now that I didn't use the right names here, but never mind. So it will put to one of our endpoints. That one will this will then call an Azure Logic app, which will post information into the Cosmos multi-master database, which can then also be read from the other data center, or should we be forced to fail over to the other data center, we can just as easily just put everything into the Cosmos multi-master thing, because even though our West Europe site crashed, Cosmos is still available to us. And the last thing that it successfully wrote into Cosmos and then got synced is then available in the North Europe thing. Once again, 99.999% SLA. It's better than I usually find myself in when working with old on-premise stuff. So this has been a travel and a half, and I hope that some of you are still there. I can see. Thank you very much for keeping that, because now we're going to do the demo thing and look a bit into the portal to see how you can use this and configure this and see that, yeah, it's quite easy once you know how to do it. So I am going to switch over to Azure. And this is the Azure front door that I have configured for myself. This is the start page. And yes, usual, you have like the usual thing, or number of requests and blah, blah, blah. You can see that I've done some testing earlier today, obviously, to do to see what works and what does not work. Sorry, I'm going to do a thing on the other screen there. So now I think everything will work better. Okay. When you create this, you can see that it doesn't say region anywhere, right? Because it's a global service. So what you do is that you go into this thing here called the front door designer. And the front door designer is designed in a way that even I can effing understand it. You go from left to right and you fill in whatever it is you need to fill in, right? So when you configure this first, you get to decide like what domain do I want to host this under. So I choose michaelsand.frontdoor, and default is .ad/azurefd.net. And you can of course tie this to your own thing. You can use seed name magic together with star certificates and so on and so forth. And I'm going to start by trying to demo the, I wouldn't say easier, but the shorter thing of doing web. So I've done a backend pool here, and I've named it my backend pool because, hey, I used a walkthrough. And what you do is that this is the pool of available services that you want to put Azure Front Door in front of, right? So I have two websites. It's called blah, 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 1 and 2. And I've set a priority and weight to it. And what is this? Well, the lower priority number, the more likely it is to pick this one, because actually Azure Front Door is not primarily designed for failover. It's designed as a load balancer. But I wanted to point as many requests as possible to one of my websites because I'm trying to illustrate a point. So I've given it the highest priority, priority 1, and a lot of weight compared to the other one. This one is placed in East US, and this one is placed in West Europe. And then you have to configure health probes. And this is usually set for you automatically when you do things like this, because what it needs to be doing is that every X seconds, and I've written down 5 now because that's the least you can have, it checks, is this service alive? If I get a call, can I route it to this service? So therefore you configure your pool. And then you have your routing rules. And your routing rules point to those pools. So you can see point to backend pool. And this basically says that I'm going to use this front-end domain. If someone calls that domain with a /web, please feel free to do that now from your browser, should you feel a bit bored. You will get back, I will then simply forward this request to my backend pool. So, and then the backend pool decides should this go to West Europe or East US. So that is very, very, very easy to do. I'm going to show you something which I personally find very, very clever, is that if you set up a new routing rule, if you set up a new backend pool, and you set a backend here, you can choose a backend host type. And there you can automatically actually point to your API management, which you might have in your subscriptions. So everything is like pre-filled for you. Or you can do the same with your app service, which is one of those things here. I find that very useful because text boxes that are free text scare me when there are drop-downs available. So, okay, sure, let's try this out then. So I get Michael frontor dot blah, 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 blah. And if I take this and put it into, so let's see if I can do it here instead, because I'm once again trying to make a point, /web, I will actually get back something which I don't want to, because it then like redirects back to this one, but it says, hey, from East US, because it redirected to that one. However, I don't want that. So I'm using Postman. And I'm using Postman to call to this exact same thing. So it's calling to, let's see if I can do a bit of magnifying thing here. So you can see that it says Mikael Sand, front door, azurefd.net/web. And this is basically just calling straight into this thing here. And if I do a preview, I can see that it says, hey, from East US. So even though I just did something here, I know that this has been to the East US and back. So one way of trying to demo this, and let's try to demo the failover feature. I'm going to do that now. It hasn't worked earlier, but I'm going to march forward anyway. So I am going to stop this thing here. And this to me simulates that this thing is no longer available. So if you were to go directly to this thing, it would simply say like 403, it's not available to you right now. But would you then wait long enough? The Azure front door should pick up that this is not available and say, okay, sure, route it to West Europe instead. Now, here's the tricky part, is that I've done this a couple of times during the last couple of days, and the failover thing seems to be, it doesn't seem to take 5 seconds. So I'm stalling for time now. So now I'm going to send the thing again, and it says 403. So your web app stopped. So this would then be, it's obviously noted that this has stopped, doesn't work. But if we were to click this enough times, then it would all of a sudden say, hey, from West Europe, because then the call went into West Europe. Thank you, demo gods, it's there. So you can see that it says, hey, from West Europe. I haven't changed anything anywhere. The site went down, the Azure front door, the probe noticed that the thing went down, and then everything just, went over to West Europe instead, which, given its history, might not be a good thing, actually. So I'm going to start up this thing again, and should we then wait again, it should go back to East US, but I guess for time's sake, you have to trust me on it, because it will probably say West Europe for a while. The reason why I'm using Postman instead, of course, is that if you're sitting now with your computer, you might be following this live or later, and you're doing this in your browser, this hey from West Europe thing might not come up, and I'm not saying that never mind. there's a lot of caching going on in your browser, basically, and there's no caching going on in Postman. So that's why I'm using it. It's simply just requesting everything for the first time every time, which is exactly what I want, right? Okay, moving forward to the more advanced stuff. And this is where it doesn't hurt if you have done a bit of integration, but then again, it's just services calling other services. So if you're not an integration developer, please don't sign off now. So let's see, what am I trying to prove here? Yeah, I have something else. I have something called the API backend pool, and I have the APIs here. So this is configured to have these two things. Have the same thing again, priority 1, wait 1000, because I wanted to go to East US as much as possible, but then again use West Europe as a failover should this not be available, right? And also I have a bit of a hack here. Should you do this yourself and add a backend there, where it will suggest another way of checking the health probe. If your thing is available, but if you put this in your path, status -129 and then A through F, you can do this for your API management needs, just to see that everything is up and running and you can actually contact it. So you simply take whatever address you have to your API management and go /status blah, and it will respond back with, yes, this is up and running. So I do that every 5 seconds to make sure that these are alive and well. And then I also have a bit of routing here, and the routing is basically if someone does not say web, that's basically what I'm saying here, then forward it into to this API backend pool. So now let's go through a bit what will happen. So what will happen is that this will be received into an API called economy transaction, which is within your API management, this API management thing under transaction/submit, it's a post. We will send a post with some information. It will take that information and it will call an Azure Logic app called failover test write 1. The Azure Logic app, it's this one. And if you go into edit mode for it, you can see that it simply receives this call. I'm going to add the location of this this logic app, very, very, hacky, saying, yeah, East US, it's written here. And then I'm going to put it into the into my Cosmos DB and then respond back there with everything worked just fine, because it usually does. However, what I would like to point out here is that this is the same Cosmos DB I'm using for the logic app that is placed in West Europe. So therefore, it's just one Cosmos DB. You don't have to trouble yourself with things like synchronization or something like that. You just pay and everything just works. Going back here, you can also see that this is located in East US, as is this one. It's also located in East US. So in the end, everything will reach this this Cosmos DB. This Cosmos DB is configured as being, it has read locations and write locations, but it doesn't have really like a place where it originates or lives. And you can do a couple of cool things here. You can look at features. Sorry, that was the totally wrong thing. Replicate data globally. And here you can see, given time, that I'm currently hosted in East US and West Europe. You can even see it on a map if you don't know where Europe and US is. And you can also, of course, then add like Australia Southeast should you do that or not. Since it's configured like with multi-region rights, these are grayed. It's because, well, basically it handles all this for you. And yeah, that's about all I'm going to show you about this now. Within this, you have the Data Explorer, and then I have a container here called Logic Apps, and then within Logic Apps, I have something called Orders, and here are the items for the orders. And I'm going to show you this now because I'm going to say like, oh, look, something new happened. So we can all see that the last one was an invoice. It had it was written at East US. So in order to test this, I'm going to go back all the way to my postman. Now the postman will send this to the front door, and it will send this thing here, and it says economy transaction submit, and it will send an almost randomly generated body. This is like a pro tip if you ever worked with Postman but don't know about these. There are a lot of random things you can do within Postman to get random generated data. So you can get a typical transaction count, or a price, or a random BS. And I leave it up to you to try to fathom what BS means. So I'm going to click send now. And what will happen when I click send is that this will call the Azure front door. The Azure front door will send it on to one of the two data centers, either East US or West Europe. The API management will pick that up, execute the logic app. The logic app will write that to our centralized store, which is available to us everywhere and all eternal. And it will write it to there, and then it will return back here saying this, like, where did I post it and what order ID was it, right? So I'm going to click send now, and it will take a couple of seconds, and it says East US, and it says order ID 231950078. So if I go back into this one here and go update and look at the one on top here, it says deposit. And then if we find the order ID, we can find that it's 231, la, 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 la. It's basically the same. This is the thing that, it simply worked. Yay, hooray. Once again, the demo gods are with me today. So the last thing that I'm trying to make happen now is that I'm going to make the East US thing unavailable to us. And let's do this again a couple of times and see if it fails over to West Europe. And it probably does. So I'm going to go to API backend, and I'm going to fake an outage by simply saying I'm going to disable this one. This is a very cool centralized thing to do as well, because if you do this, then click update, and then click update, and then click save, all the calls should be routed to the other place, which then means that you can now go and do maintenance, whatever it is you want to do in forms of deployment or whatever, into your East US site and do all the updates there, and then roll over and roll back to the other one. So we can centralize it on a central level. Yes, in a centralized way. In a centralized way. So I'm waiting for it to successfully save, because this will probably take some time, because if I do a new call now, it would probably go back with East US anyway. So it was still written to East US. We have to wait for a while for it to understand that the East US thing is not available to you anymore. You shouldn't use that. You should send it to the other one. But I should then go back to the called front door website again, which last time we called, well, East US was down, so it rerouted to West Europe. And if I do this again, it should point to East US. So there you have the failover thing. I'm going to click this a couple of more times, and if it doesn't work, I'm going to proceed with something else. And 2, 3. Hey, and now it's been rerouted to West EU. And if we go back into our database and do an update, so update this thing, select the top one, we can see that we have written at West EU, which basically then means that we are selling Erna Wunsch front-end architect e-tailers for 570 something. But we have written it to using our West Europe instance, because our East US was down. So therefore, you know that the Azure front door failover thing works. Now, actually, since I've done this presentation before, and there's actually been an added bonus to the front door since I've done that. And this is the rules engine configuration. I'm not going to do anything. I'm not going to demo anything, but I'm going to show you that it's there. And you should be able to know that this might become very useful because you can add a rule. So you say that, okay, add a condition. If someone sends in from this remote address, if this is equal or you have an IP match to a certain IP, then you should do an action thing like, go in and add a request header, call this and have this value. And I think you can then do a lot of cool things using this information in your downstream system. So we can actually know that, okay, sure, it originated from, let's say, Australia, and therefore we need to do something additionally within your application. I found this a couple of days ago. I find it extremely useful for a lot of things that I've done from an integration or web integration standpoint. Given that, I am now going to jump back into a couple of slides, and then it's question time, should you have it. I see that there's actually been some questions, so I'm going to answer them. But now, how to make it work for you. This is a greenfield kind of thing. I know that. I realize that, of course. However, there are a couple of things which if you do these things before you start, things will get easier for you. So you have to be sure to remember that you usually have something like for deployment, of course. So if you have two completely identical resources, you need to, if you do an update, you need to deploy it at both places. So if you add an API to API management, or you add a page to your web app or whatever, you need to do that twice. And in order to do that in a good control way, of course, you do it using CI/CD, and you do it using release plans. Because if you don't, you will end up with misconfigured environments. You have to remember to access rights. So some very keenly eyed person among you noticed that I was able to call API management for two different instances, but I didn't do anything with keys or anything. And that is the reason behind that is that I hacked the API management instance. So both API management had the same access keys for the two different APIs, which is a way around it. You can use other services to do that, but I just simply used the API and hacked it. But also you should make sure then to have, if you have things which are dependent on where it's executed, you should make sure that you have access rights for like both instances, either like East US or West Europe. So make sure that you do that. And also with everything, it's the weakest link determines the overall success, right? So let's say, for instance, that you have this cool thing in place, and you want to make it redundant, you want to make that work, and the guys that you're calling the backend, they say, yeah, we're in Azure, so everything works just fine, right? And they're hosted in West Europe as well, and your West Europe instance goes down, and you say, whoa, so you turn over to East US one, but you call the same service which is hosted in West Europe, and their service will be down. So the entire link will be broken and it won't work anyway. So, you have to remember these things, and especially when it comes to things like working with single service server instances in an on-prem environment, then the SLA goes, out the window. And also remember that SLAs are cumulative. So it doesn't, the highest doesn't count. It's cumulative. So it's lower than the lowest. Should you want to study this further, if this speaks to you either as a person or as a work environment kind of from work or whatever, I have written an 18-pager about this whole thing of like RPO and RTO. You can see out to the left there. If you contact me, I can make sure that you can get access to it. We also have a more, let's call it a more work-related presentation upon this, which you could do to perhaps further the knowledge about the problems of geo-redundancy on a CXO level rather than you guys, because you understand this now, right? And by that, it's question time. So I'm going to look at I actually have this on my phone as well. And yeah, it's been lagging a lot for you. I'm very, very sorry for the start there. I thought I turned on the sound and then I didn't. Yeah. And you're talking about something called the CAP theorem. Yes, it's the exactly same thing, actually. Not exactly same thing, but it's basically evolving the same thing, that you can't have anything or everything at the same time, you know. What if the logic app runtime fails? Well, that is a very, very good question. So in this particular case, what would happen? So if my runtime would fail, I would probably return back an error, and I would return back that error, even though if it wasn't redundant or anything, it will still return back as a 502 to the caller and basically say, hey, something went wrong. Here's the information about what went wrong, or what's it called, a run ID, which is usually what you get back. So it doesn't have any impact on the redundancy per se, because it's basically the same as saying, what if my application has an unhandled exception? So you still report back, but they will get some information back from you. If you don't have redundancy and your data center goes down with your application, they will get back I wasn't able to contact it. Yeah, okay, sure. Cost of redundancy versus the value of redundancy. I'm going to do one of those consultancy thing and go say, well, it depends. Because, of course, it depends. In the paper that I wrote, I tried to make a clear point of redundancy might be very costly, not because of like services costing a lot of money. I mean, Azure Data Factory, Azure Front Door, Azure Data Factory. Where did that come from? Azure Front Door is not a particularly expensive service. Don't remember the exact thing now. You can Google it. However, I was more aiming for like, okay, sure, there might be some added cost, of course, of all this. You need to deliver everything twice. You need to build a really good CI/CD thing so you can, with confidence, always deploy everything just once, and it will be deployed all over your instances, all over your data centers. So that is a cost. It's an added deployment cost. But what is the cost of downtime? Is if this service is not available to you guys for 1 hour, is that a problem? Okay, sure, it's not a problem with 1 hour. If it's a problematic if it's half a day, yes or no. But if they say something like it can't be down for even more than a minute, we need it to reinstate itself in a minute, and we shouldn't have lost any. If you're doing things like ticket sales or something like that, it's a given. It's an open and shut case for having multi-data center redundancy, whether it's large scale or small scale. And then it will cost money, but it will cost them even more to not be available and not sell those tickets and get all the Twitter or whatever you send in on Yelp feedback on this ticket system saying like, oh, you can't keep up with the load. So Nubo, I'm not exactly sure. You've written 2 API management instances. Yes, I'm using 2 API management instances. I'm using there is within the very expensive, the premium one, sorry, it's not expensive, it's the premium one. There is a failover thing which then they handle for you, which might be good. It might also be, not that good. Going back to like this, what I said, 1 hour versus half a day, one of those things which our clients found very, very frustrating was that they couldn't do anything. They couldn't push a button to basically say, can I fail over now? Can I do this now? Can I make something happen? I want to, when are you guys done? Right? That's the thing. And sometimes half a day might be extremely painful, and other times it might not be that painful. So you need to make sure, and this is in my white paper that I've written as well. It's like I have like a grading system on how important is this stuff to you, and if it's the highest level, then you should definitely be redundant. There's also a okay, thank you very much. I just read your feedback there. I was complete right. No, I don't have an experience of using the rule engine. I am very much going to take a look at it, probably tomorrow, because I can immediately find about 3 or 4 cases where I wished I had that to basically either turn people away at the door by simply going, if you're not from this IP address, you're not getting to my data. That is one thing, one way you could do it. Yes, and then active, passive thing. So the thing I've done now is to have an active passive, basically, because I've been configuring it to use one data center as much as possible. Going back to this thing here, I'm going to go click around here. So within this designer, that's the thing I've done here. So I basically set this to an active passive thing. Oh, sorry, I'm being an idiot. It's in the backend pool. This is basically an active passive thing. We've also internally had the discussion on having, let's call it a cold standby, or rather even a pipeline standby. So what you have is basically you have a normal deployment to one place, but you can just start a new deployment of your platform to the new place should you need it. So let's say, for instance, that you have something very, 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 very big, very costly, very large. You don't want to have double costs because of running time, just to be sure that you can flip over. So what you could have is that everything you've deployed to one place is redeployable, and then you redeploy it and just pointing to the other data center. Yes. Azure Data Factory is not Azure front door. So there are levels for it. There are a couple of caveats when it comes to doing these things. I'm not going to go into network related stuff because one, it's not what I know, and also it's not my forte. I don't like connecting to or being tied down to a network because it usually infers a lot of rules and it makes my life miserable and poor. But however, I would like to point out that there are still things that might not be out of the box available for you. One such thing might be if you're using things like hybrid connections or on-premise data gateways or something, which they are usually tied to. You have one installation is usually tied to one data center. So therefore, you also need to make sure that you double those services on premise to make sure that it can handle loads from all over, not all over the world, but from different places in the world. Yes, CI/CD automation is 100% crucial. As ever, I can only agree. There are a couple of things which might not be even able to be deployed using templates and CI/CD, but you should really strive for it. If it's not supported in the CI/CD process, please consider that you might not use that service, or perhaps that developer. Kind of depends. So we're coming up on a whole hour now, and I think there's been no questions for a while. So once again, thanks to our sponsors, Active Solution Director Cornerstone, and for Forefront Consulting, Microsoft, and PwC. Also, would you like to hit me up? Please consider using Twitter at Mikael Sand. It's very easy. You can DM me there or anything, and let's take it from there, should you want to know more about this. I don't know when the next session will be from the Azure Meetup, but I know there will be sessions. So there will be sessions down the line. So I just got a question here. I will not be able to share the white paper publicly as such, because it's internal intellectual property. I'm sorry, it's not one of those things. However, if you contact me and if you talk to me nicely, and then perhaps we can work something out. But other than that, that's all I can give you from now. I'm sorry for being such a bore. Just going, that's not available. It's not my fault. Sorry. Also, thank you, Andreas, very much for saying thank you. And I am going to stop streaming now. You guys have a great